Okay, good evening, everybody, or good morning, good afternoon, depending on where you're connecting from. It gives me great pleasure to introduce the closing keynote for COMSNETS. This will be presented by Professor Ellen Zegura from the Georgia Institute of Technology. Helen is very well known in the networking community. She's been doing so much seminal work in this space, in internet topology, in wireless networking. She's the current chair of ACM SIG Mobile, and we are still hyper grateful to SIG Mobile for providing student travel grants and enable quite a lot of you to attend, by the way. Ellen, if you look in the room, you'll see the room is full with a lot of people attending on SIG Mobile travel grants. Thank you again. This is a fantastic talk to end the session with, because Professor Zegura is going to take us away from the technical side of networking and tell us about human-centered networking, which is how do we use networking technologies for social good. And I think that's a fantastic topic to end COMSNETS with. So without any further ado, I'll hand over to Professor Zegura. Thank you.
Thank you, Rajesh. I'm delighted to be with you all, and I wish I were there in person. I'm the chair of SIGCOM. I just wanted that one tiny correction, just so the chair of SIG Mobile doesn't think they've been replaced.
Oh, did I say that? I'm sorry.
You did. You're probably, they're interchangeable for the purposes of this. So I as I was talking to Rajesh in the backstage room, waiting for it to be 8 a.m. here in the East Coast, I was remembering that almost exactly 3 years ago, I was in India, and it's actually the only time that I've been there. It was for the conference called Information and Communication Technologies and Development, ICTD, and it was in, and I won't say this quite right, Ahmedabad, and one of the highlights for me was visiting Gandhi's ashram. And I guess it feels appropriate that it was the ICTD conference that took me there, because in fact, that's a conference that really does focus on issues of the intersection of technology and political, economic, social development. So very much kind of human-centered computing conference. And I've had the pleasure to be involved in it now over almost a decade. So let me give you an outline for what I'm going to talk about today. And I'd welcome you to put questions into the Q&A. I probably won't answer them during the talk, but I may keep an eye on it now that we teach virtually all the time. We're used to kind of watching the Q&A as well as watching the room. And I really appreciate whoever's controlling the camera in the room. It's wonderful to have a chance to see some faces and not just be talking into a void. I guess that's a heads up for those of you in the room. I am looking at you. So I'm gonna divide the talk into three parts, and they're quite different in length. The first is the biggest, the second is the shortest, and the third is also not too long. So the majority of the talk I'm going to be spending on the first part of the outline, and that is I want to talk about the digital divide, because I think this is probably the most important and in some sense most obvious example of a human-centered networking problem space. Then I'll mention some other human-centered networking problems, and finally talk about choosing work for the future. I know that many of you are students, and so you will have a lot of opportunity to choose problems to work on over your career. So maybe there's something I can say there that might be useful for you at some point when you do find yourself making choices about problems. Okay, so I want to start in talking about the digital divide by talking about access links. I would say that for a very long time, access links didn't get much attention in networking. When we talked about the network, we very much meant the core. We very much meant the core, or maybe we meant the ISP that allows you to get into the core, but we kind of didn't pay a lot of attention to access. Access is pretty interesting, both technologically and, of course, incredibly important when it comes to the performance that users see. So Access 101, access is the last mile. I put mile in quotes because Depending on what technology you're using, it could be, it could be the last meter, or it could be the last multiple kilometers. So last mile is the terminology we use, but we don't mean it completely literally. There are rich and varied technologies for access. All of those that are wireless are spectrum constrained, and that really produces some interesting effects. We talk about access in two categories, and that's rather important because many things differ about these two categories. So fixed broadband access by a fixed location technology, and mobile broadband access via mobile location technology like cellular or satellite or Wi-Fi. I understand that Wi-Fi is going to be dead in 5 years, so I'm not going to talk about Wi-Fi. That I've been told Victor Ball shared that as a prediction. So the term broadband, when we talk about access, we frequently want to and should be talking not only about do you have access or not, but we should be talking about what the quality is of that access, because that's a when we talk about digital divide and variations, disparities across what users have available to them, performance disparities are a huge and important category. So, and the term broadband, I'd say this was surprising to me when I first realized it, is actually a contested and evolving term. I don't know how across the whole, I don't know whether how much of this is US specific and how much it shows up in other countries. So that would be interesting. Maybe in the Q&A, some of you could either speak to this or I don't know, don't ask me because I don't know. But in the United States, the definition of broadband is contested, and it actually has a political impact. So here's some sort of very basic questions about if you were in charge of defining broadband that you would have to answer. So one is, should it be the minimum speed that you are able to achieve, or should it be the median? Should it be what providers advertise that they can provide you, or should it be what you measure? These are if you're going to give a definition of a quantity, right? You have to answer these questions, and you can see why providers might prefer that you use the advertised speed, because then they can claim that they offer broadband over a wide geographic range, when in fact it could be that many users in that range can't get that advertised bandwidth. So you can see why there could be an economic reason to favor a particular definition. Also, if your government has made a commitment to citizens to provide mobile broadband or mobile broadband, if they make the definition easier to achieve, then they can claim success. So, and I won't spend this much time on every slide, but so broadband is contested. In the US, our Federal Communications Commission, the FCC, has jurisdiction over this. And the current definitions are 25 megabits per second down and 3 up for fixed. And then there are 2 definitions for mobile, one for the minimum and one for the median. And you can see those are 5.1 and 10.3. I made I didn't say this. I talked about whether you could achieve it. It's important to make a distinction also, not only between what's advertised and what's measured, but between what is made available by our provider. So those are the deployment numbers, and whether consumers have purchased from deployed options. And when we ask whether consumers have purchased from deployed options, we are getting at issues of affordability. So just because a provider offers, say, mobile broadband in my area, I may find it to be too expensive. So in some sense, there's coverage, but in a real sense, in a human sense, if the coverage is not affordable, it's almost as bad as if it's not present at all. Okay, so that's background on access. Because you're an international audience, I wanted to just include a little bit of additional non-US perspective. If thought I could find the data. I would have tried to do this for India, but the UK was available, and I think makes the point that this does vary, of course, by country. So in the UK, they just have a completely different definition for coverage. So 4G coverage is defined as 95% probability to complete a 90-second call, and 95% probability of at least 2 megabits per second download. So that's interesting. It's a different statistical, rather than reporting, say, median, they're reporting a kind of tail, upper tail. And at least in the first case, it has to do with something a user might want to do, make a phone call. So that's interesting. And the way they report their coverage is by landmass, not by population. The US does population. And if providers don't meet these targets, they have some serious legal sticks available, including fines for providers. And that's a sort of fascinating to me, because one of the things that's extremely difficult about access is that in areas without large populations, providers find it economically disadvantageous to provide coverage, because there aren't enough people to cover the costs. So having a serious stick for providers is an important part of being able to get universal access. So an interesting question about the digital divide is, what do we know about it? So how do we, what do we understand? What data is available about? And now I'm really going to focus mostly on mobile broadband, cellular mobile broadband. And so when you ask this question, okay, what do we know about it? Who is collecting data that might, who has or collects data that might help us paint a picture, have a map of mobile broadband access? So that space is interesting, because there are multiple stakeholders interested in access data. Maybe I'll jump to the second one first. Providers, mobile broadband providers, are definitely interested in knowing where the reach of their networks, and so those providers possess data about their own networks, of course, and from those some reasonable picture of what their access looks like. It's not a perfect picture. I'll talk about that in a minute. In the United States, those providers are required to report in the form of shape files what their coverage is. So, for example, AT&T provides on an annual basis to the FCC shape files that show AT&T's best estimate of where their coverage is for mobile broadband. So connected then to the second to providers is the government. In the US, it's the FCC. There's Telecommunications Act from 1996 that requires that deployment to all Americans be on a path to that. And in order to monitor that progress, the FCC aggregates provider data and does some of their own independent collection of data by users, and then publishes that, makes that available. Speaking of users, I'll go back up to the first of these. Users collect access data to monitor their own performance. So some of you may have done speed tests before, or other forms of network measurement on your own device. It's kind of interesting. If your performance is bad, it helps confirm that. Can be used to hold providers accountable, although that's a complicated challenge process. And users may do some of this measurement because they are inspired to contribute to crowdsourced data collection efforts. An interesting collector of access data is location services companies. And in my own work, I've been partnering with a company called Skyhook that provides location services. In order to do triangulation to improve location, they collect signal strength information that's essentially embedded inside applications that users have agreed to have this taking place. And they wind up with a very rich data set that's essentially crowdsourced, but sort of crowdsourced in the background for users. And then finally, researchers, and I'll share an example in a minute from my own group, will collect access data. Of course, not on any grand scale, because that would be logistically impossible. But it's quite helpful if you want some form of ground truth and in a particularly hyper-local way. The kind of data that's collected varies from quite basic, what's the upload and download speed at a given location, to a little bit more complexity, latency, for example, to a nearest server, or a collection of servers, and then kind of increasingly, I guess, more closely coupled to user experience, but also more overhead associated with collecting the data, various kinds of application performance like web page transfer time, quality of experience metrics for video, and then not so much a packet level collection, of course, but the various ilities. What are the pricing plans? Are they affordable? Reliability, perhaps a measurement, and quantity. And then for mobile, separate from, so all of these are collected for fixed and certainly can be collected for mobile. For mobile, there are also physical layer properties that are measured. So signal strength, and also who's the provider, because of course that matters. What's the radio type? What's the location? And I've noted too, in both places where the word location appears, as soon as you have collected data with location, you have privacy concerns, because that means that a user was in that place at that time in order to make that data collection. So in the mobile case, frequently a question of interest is very simple, which is the signal strength above a threshold? So if all you're collecting is signal strength and you want to know something about quality, you can make that a binary by just setting a threshold and saying below the threshold is not connected, above the threshold is connected. That's very, very simple form. So now I want to turn to what we know from crowdsourced user data. And the reason why I'm focusing on that, actually, let me go back to this for a second. Provider data has a number of limitations to it. The main one being that providers are reporting based on a model for propagation from their infrastructure. And we all know that a sort of circular disk model is not a very accurate propagation model. So there are limitations with provider data. Crowdsourced data, user data, and crowdsourced data holds a lot of promise for being able to provide measurements that have been taken at the place where users are. So I want to talk about what that what that has meant and sort of state of the art of crowdsourced user data. This comes in, we can sort of do a bit of a taxonomy of user crowdsourced data, whether it's active measurements or passive measurements, whether those measurements run in the background, meaning, the user at some point has clicked the box that says, I agree to allow this, or whether the user makes a choice to take to make the measurement. And then what happens with the data? Is it publicly available? Is it available in aggregate form? And then last, is it privately controlled? So the Skyhook partnership I mentioned, that data is not publicly available. We have a data use agreement, and so that's this is an issue with essentially who can access the data. So Many of you may be familiar with Ookla. Their speed test application is very popular. It's an active testing application, user initiated. It's available for both iOS and Android. And they share they share aggregate data. There are two forms of aggregation. There's both a time aggregation, and in their case, it's a 3-month time window. And there's a space aggregation, and they use Z equals 16 tiling. That's a 600 square meter gridding of the globe. And that data in its aggregate form is publicly available. They use that data in highly aggregated form to do things like report on crowdsourced user performance across at the country level. And so they have this global index for the highest mobile global average and the highest fixed global average. And I just offer these to you, I guess, for interest. They're different. So mobile deployment and fixed deployment do not fully track one another by countries. And neither the US nor India are on either one of these lists for March 2021. You can see on the right-hand side that the US was 19 for mobile and 14 for fixed at that point. And then a month later, a little bit, US had moved up a little bit. So that's an example of Ookla data use. Here's another crowdsourced a data set. This is OpenCell ID. This is active testing, user initiated, and a collection. The data collected includes the radio type, the cell ID and location, and also can collect things like signal strength and several other measurements that are related to physical layer kinds of metrics of interest. This data is shared by country and radio type, and there's an access key that allows you to get access to it. So I wanted to give you an example of the quality of OpenCell ID or quantity of OpenCell ID data. So this is a map very close to my house. Actually, my house is hidden by the pop-up in the middle. And so this is this tells you that at this particular location, that pop-up window, UMTS rate for the UMTS radio type, there's one measurement in the Ookla data set, and that was taken in 2015. So I show this by way of illustrating that these crowdsourced systems like OpenCell ID are really quite sparse in their data. Here's another example from the UK, right by the Department of Computer Science and Technology in London. And here there were 6 measurements, but those all took place in 2015. So, one thing that happens is when a crowdsourcing opportunity comes along, people first learn about it. They're kind of excited. They give it a try. And then that's it. that's the end of the measurement. So you see that both in that US example and in this UK example, those measurements were taken in 2015 and not updated since then. So when we think about crowdsourced data, it's interesting, but it's highly variable in quality. Crowdsourcing is always biased by what part of the crowd decides to participate. And one of my collaborators, Elizabeth Belding at UCSB, has some data showing that participation scales with income, not surprising at all, meaning the more wealthy, the more likely you are to participate in crowdsourced data collection because you know about it, you have the time, you apparently have the inclination to contribute. Maybe it's scientific curiosity. And it's also biased on when people participate. So, I'll pose it as a question. Do people mostly use speed test when their performance is bad? there's probably pretty good reasons to believe that there would be a skew that people would measure when they were experiencing poor performance. There are other data sets available from other crowdsourced data sets. Mozilla has a relatively newer crowdsourced data set for mobile access. The MLab has some data, and then OpenSignal, it's not actually clear to me how open the data is for OpenSignal. And I mentioned Skyhook, which is this proprietary data set. So, and there are actually a number of myths that exist about our understanding of mobile broadband. One of them is that we have all the data we need. The second is that broadband access problems only appear in rural areas, and in the U.S., that kind of myth might be used to say that, well, almost everybody has access. Another myth, and I alluded to this, is that cellular providers know their coverage accurately. They don't, because they're not going to go out in the field and make all these measurements, right? They're basing it on infrastructure locations and models for propagation from infrastructure locations. Related, a myth that the performance is easy to predict from propagation models, not true. A myth that a federal agency will figure this out. I mean, they don't have any magic that allows them to be everywhere all the time making measurements. And last, that 5G will somehow solve all problems. This figure has to do with current 5G deployment. And obviously the continent of Africa, and there's only one example of 5G deployment based on Ookla's measurements and in the entire continent. So, I mean, yes, 5G, but not for a long time. In fact, I think 5G will increase the digital divide for a long time, meaning make it worse before it makes it better, if it makes it better. So I want to drill down now into some of my own work. That was mostly background, and talk about a project with a number of pieces to it that has to do with mobile broadband. So I've talked a lot about what you do and don't know with words. So let's go to a map, a picture. So this is the state of New Mexico in the United States. It's in the southwest portion of the country. It's a state that contains mountains and rural spaces, a couple of cities. It's not a highly populated state. It also has Native American tribal lands, which is one of the reasons why we were interested in choosing it for our work. And this is data from 2019. The provider here is Verizon. So, of course, I have to tell you the provider before you can appreciate, that's highly relevant to the data. And there's a picture with 4 colors, map with 4 colors. Each of those colors represents one of 4 possibilities when we compare what the FCC data sets tell us about where Verizon provides coverage and what the Skyhook data set tells us about where Verizon provides coverage. So 2 data sets, 4 possibilities. They can agree in a location about coverage, that there is coverage. They can agree that there is not coverage. And then they can disagree in 2 different ways. One can say yes, the other no, and vice versa. So here, the orange is the places where both data sets agree you cannot get Verizon coverage. So there's a fair amount of geography in New Mexico where Verizon is not an option as a cellular provider. The blue is the other example of agree, and that's the largest land mass is the blue, where both agree that Verizon provides coverage. The other 2 are in many ways, well, the orange is interesting because of issues of who has access. The other 2 are interesting because they point to data set discrepancy and difference. So the purple is where the FCC, which remember comes from the provider, says there's coverage, but Skyhook does not show that. And the dark blue, and there's a decent amount of orange in here, And then the dark blue is the opposite. So Skyhook has seen measurements there, but the provider says they don't have coverage. Not much dark blue. And interestingly, it makes sense. The purple is frequently a boundary between the orange and the blue. So orange, everybody agrees there's no coverage. Blue, everyone agrees there is coverage. And it's that transition region. Where is it that you go from not coverage to coverage that you see this disagreement? And basically what you're seeing is almost certainly providers overstating their coverage because they've used models, propagation models from their infrastructure that are too generous. So a number of things to take away here about the state of mobile coverage, if you focus on the places where these agree, and also about the state of understanding of mobile coverage. And that is in this sort of disagree category. The provider does matter, of course, the cellular provider. So this is the same New Mexico map. And instead of Verizon here, it's T-Mobile on the left-hand side and AT&T on the right-hand side. And AT&T is well known for not being very good in that region. You see the large mass of orange on the right-hand side. So of course, providers are operating differently in different regions, and so it does matter which provider you are focused on. This is an example a little bit closer to my home, to Atlanta, Georgia, and one of the reasons why I wanted to show this is because, as I said, New Mexico has a number of rural and mountainous areas. Georgia also does, but what I'm showing you here on the right-hand side is a county called Pike County. It's very close to Atlanta. It's an hour and a half drive from Atlanta. And here, the dark orange is where fixed, switching now briefly just to fixed broadband access, served versus not served. And what you see is this precipitous drop. As you move away from Atlanta, those counties are highly, highly served. And then you reach just an hour and a half away, and you find a county where essentially almost only the county seat, which is shown in it's the dark orange on the left-hand side, is served. And the rest of the county, that county is something like 70% unserved. So they cannot get broadband access. They can't get fixed broadband access. And they're an hour and a half from Atlanta, which would be a surprise to almost anyone who hasn't looked very closely at this kind of data. And there are also data discrepancies. So I'm not going to belabor this, but Georgia, the state, has its own broadband deployment data. And when it's compared to the FCC data, again, in the fixed category, there are great differences. Those are probably about affordability, is my guess. So I've been pursuing with collaborators a research agenda around the digital divide, and basically has 4 components to it. One is mapping the digital divide, and particularly mapping mobile access. So how do we improve maps? How do we improve our understanding of mobile access? That ties into measuring mobile connectivity. I'm wondering if now you can't hear me. Oh, they're back. All right. And then going beyond connectivity, and finally, sort of the holy grail, which is to think about how we might bridge the digital divide. So let me talk about measurement for a minute and what makes it hard. So I've alluded a little bit to this. Propagation models have their limitations. There's spatial variability in performance, mobile performance. There's multi-scale temporal variability. Is it raining or not? Is it have the leaves fallen off the trees? Has new infrastructure been deployed recently? In a case in that county I mentioned, there was they put up their own municipal ISP, and then film crew came to town to do some filming and set up their trucks. Their trucks blocked the signal. So, all kinds of ways that connectivity can be good and then not be good. There's also a lack of ground truth that's a serious issue with respect to doing this work and being able to evaluate how well your techniques work. And then finally, that crowdsourcing requires a crowd. So in order to incentivize crowdsourcing data collection, my students and I have been working on an app, and we have targeted it specifically at people who are hiking on trails, and because trails are frequently through more rural areas, and hikers actually do care about where coverage exists, for example, for safety purposes. So we also, this was a Native American project. We couldn't travel to New Mexico during COVID, so we wanted a location that was close to home and safe for doing measurements. And so we did this pivot to trails in the mountains. So HikerNet is the name of the application that we've been working on, and it runs on Android and iOS. It has a very simple start-stop model, and then it will display for you connectivity data from a hike defined as from the start to the stop, and then it will show you kind of collectively what your set of hikes, a list of the hikes that you've recorded, and what that connectivity is. Now, you don't have to be on a trail to use it. I've used it driving around my own local area. So I've used it while driving. I've used it while walking in my neighborhood. I've used it on trails in North Georgia. So all of those. And there's good reason to think that this tools like this would be quite valuable to communities. The FCC is interested in allowing people to challenge providers when providers say that there's coverage, allowing citizens to challenge that, to dispute coverage data as a path, of course, to making a case for investment in greater deployment. So accepting crowdsourced information from third parties is a part of the framework that the FCC is constructing. And so tools like HikerNet would be valuable to communities as they create a case for whether they have coverage or not. Let me just say, I want to say just a little bit about going beyond measuring connectivity. So, coverage is a sort of bare minimum type of measure. And what really would be helpful would be to understand performance at locations. So rather than a map being binary, to have a map that is connected to user experience or expected user experience. Of course, that's much harder. It takes much more packet level data to collect these kinds of measurements, and spatial and temporal variation will be significant there. There's a research thread on mapping quality of service to quality of experience. I think that's a good direction, so that you can take measurements that are feasible and turn them into something that connects to what users are seeing. Now I want to just give an example of some work on bridging the digital divide. And this is a project that we call LoRaX, for LoRa Extends the Internet. And the sort of setting here is, or the setting is to imagine regions or think of regions where there's currently no internet access, and at least for some foreseeable time period, that's not expected. So what to do? And this is sort of a thought feasibility exercise in IoT, IoT technologies. That's a kind of newish kid on the block with respect to linked layers. Is there something of promise there? And certainly the initial reaction would be no way, right? These technologies are way too low data rate. So we decided to kind of question that conventional wisdom and ask, what might a ubiquitous low data rate network do for disconnected internet users? So this is not to claim that this is this gives users everything they want, but if you have nothing, then is there some usefulness you could get out of low data rate and also, of course, low cost technologies. And so what we've done is we've constructed a system where users can interact with internet services through a proxy, through a tree-based network of LoRa gateways that allows you to extend reach, and can interact with services in very compact messaging, with the intention that the user eventually travels to a place with internet access and is then able to update their interaction with services at a higher bandwidth location, but get some reasonable version of the service at a low data rate. The example we've been using mostly is a commercial, is an online marketplace called Etsy. And in Etsy, sellers keep up to date items that they have for sale and quantities of those items, and then they interact with buyers who are interested. And if you think for a minute, you could actually distill these transactions into very small messages. And so I'm a crafter. I've made 5 more of an item. I can update that item to add 5 through a proxy with a very little messaging. If a buyer expresses interest in an item, I could get a very, very small message saying there's a buyer interested in an item. Then I might decide to travel to a high bandwidth location where I could interact with that buyer. But knowing that there is a potential buyer is incredibly valuable. If there's no potential buyers, I don't need to make that special trip. But if I know there's a buyer, I might want to make a special trip. So this is a project that is a way of bridging to users who have no connectivity and trying to provide some value, and in this case, in the economic viability world. I want to leave enough time for questions, so I'm gonna skip this. This is Work Local and what they are trying to do to bridge the digital divide and some serious kind of realities associated with that. So let me wrap this up and say that hopefully it's been clear that the digital divide it's an equity issue. Disparities have far-reaching ramifications for education, for economic opportunity, for healthcare. It's also a complicated socioeconomic, political, and technical issue, which tends to be very scary for people who are technologists. This little cartoon on the right, we all have our layer or a couple layers where we feel most comfortable, and generally speaking, they're pretty far down there on that stack, and yet digital divide resides really across layers, and in particular does show up in these upper layers. So now, very briefly, I want to talk about a couple other human-centered networking problems. This is the only slide on this part. And these are places where the fact that there are people really, really matters. So network management, right? People who do deploy and manage and expand networks. Video quality of experience, or any other app where users are, where the quality of users' experience makes a big difference. Explainability. As soon as we're trying to explain, we are definitely explaining to people. And then the whole realm of issues of privacy and privacy around networking. Okay, and my last slide, I just want to say that I want to talk about how, we are increasingly in a globally interconnected and interdependent world. Perhaps COVID, nothing has made that more clear than COVID. No country operates in isolation. And so when we choose problems to work on, kind of remembering that global interconnectedness could help drive some of our decisions about what to work on. What are the real broader impacts beyond the intellectual merit? I had a chat with Keshav, and he said, you want to pick a problem, just look at the front page of the newspaper. You don't need to read any conference papers. Just look at what the world is facing. And I guess to tie to my own talk here, kind of moving towards layer 8, moving towards the human, the very human components, whether they be, political, economic, socio, even if that's happening in baby steps, would be a great way to start to choose problems to work on. All right, I'm going to stop here. And Rajesh, turn things over to you, and I'd be delighted to answer questions.
Thank you.
Hi, I'm Supratik from LSU. So I have two questions. First is that I saw that you collected data from the big providers like Verizon and so on. Now there are smaller providers like H2O, which use the infrastructure of the big providers and provide service, right? So have you done any work on that? So that's my first question. Second question is that in this area, do you have any formal definition of quality of experience?
Okay, two good questions. So to the first question, so the data that I was showing actually comes from the providers have provided that to the FCC. So actually, let me say two things. I've done two things with provider data. One is access the data sets that the FCC has, and I assume that they have those for smaller providers as well. I don't know the answer to that. We chose within those data sets to pull out the big providers. But my guess is that FCC rule applies to all providers. So the small providers would be present there. As you note, they don't have their own tower infrastructure. And so, in terms of quality of their data, they're likely to suffer the same issues as bigger providers. But I think that data is probably present. The other thing is we measured in our measurement tools. It's interesting. We've found that there's some bug in our code that doesn't allow us to, or there's some issue with resellers. So Mint is a reseller, and we have not been able to measure Mint, and I don't know what the reason for that is. So I think your point is well taken that big providers are not everywhere the only option. I think the FCC has that smaller data, and then there's some challenges with building measurement tools with in labs and then trying to take them out into the world. Your second question about QoE, that's I'd say an unanswered question, and I almost sometimes wonder if it's unanswerable. We can, though we generally don't, ask people, actual people, what their experience is. That requires a skill set that many of us don't have, although more people are getting it. It also has an issue with kind of scale, right? Even if I ask 100 people, is it enough? Another good question. I think figuring out how we can best take measurements that are efficient and practical to take and map them in some way to a better notion of what people will experience, I think that's a worthwhile direction. I don't have a lot of confidence that will produce very precise measures, and I don't think humans work that way.
Okay, thank you. We have a question online, which I will read out from Costa, which is, thank you for the great talk. Do you see a global vision for elevating digital divide with LEO sats/internet via nonprofits?
Yeah, I mean, I think LEO satellites are the perhaps the next hope with respect to digital divide and getting access in places where we don't currently have it. I don't think that those are going to be, I think it's going to be a while before we would see significant constellations and understand what the price points are going to be and have those be, cost effective for reaching everywhere. So I'm curious, interested in the potential for LEO satellites for this issue, but I don't think that they're going to solve the problem, at least not in any near term. The internet nonprofits definitely play a role. And as do kind of community-based networks, community 5G, for example. Of course, you have to have an internet backbone in order for that to make any sense. It's then you get into some of these network management issues of, do you have locally the expertise, to say manage a network that isn't a commercial provider network. We've seen that in this community we've been working with in Georgia. The person there who has been working on their network said, if you can provide me some students to come down here and do network installation, that would be amazing. Because the local population is small and some combination of not trained and not interested in doing that kind of deployment. So I think LEO satellite is an important place to keep watching and to think about that as a bridging, as a component of bridging. I sort of don't think that there's going to be a single magic solution that solves all of it.
Okay, thank you. Are there questions in the room? I can't see.
Okay, hi, Rajesh. I have a question.
Fine.
Hi, Alan. Rajiv Shori from IIT Delhi. A very interesting talk. I think very insightful. I'm just curious to know, Alan, how do you think the solutions to the digital divide are going to vary from one country to another? Mm-hmm. Of course, I mean, there's no global panacea or solution, but with different, with so much of diversity and the spread all over, and we've seen that in the last 2 years. How do you think the solutions are fundamentally going to change from A to B to C? Any thoughts on that? Thank you.
Yeah, that's a great question. I can give you, just to give an example of something that's been happening in the U.S. and to be honest, I don't know if there's an equivalent, in India or in parts of India. So in the U.S., the FCC has made available the television white space, the spectrum that was reserved for broadcast television. It is now possible to use that. TV white space is the name of the link layer technology, if you know that there's no incumbent TV broadcast. Of course, we don't broadcast TV very much anymore. We mostly get it over the internet. So, but that's quite specific to, anytime we're talking about spectrum, we're constrained by and talking about whatever is the governing entity that mediates spectrum access, in the country. And so in the U.S., TV white space links are a possibility. I would say they're certainly not widely deployed, and that matters too where you are. If you're in a crowded urban area, many of those channels are already taken. But I think that is an example where we could easily see countrywide differences and different decisions made by the entities that control spectrum about what to make available, and that really could make quite a difference in different places. So, I think that mobile is especially interesting in this regard, and it is because spectrum has these political and economic pieces to it. I think it would be fascinating to see. Watching the creativity and innovation that come from local solutions, I think is very powerful in this specific domain. You see examples of places where, I can't remember now. I have data from a country, but I won't be able to remember which one it was. It might be Liberia in West Africa. They had a devastating civil war. Their fixed phone infrastructure essentially fell off a cliff. It went to zero. And it never came back because there was no reason for it to come back. You know, it was all mobile. And so examples of places where local conditions, local creativity have, you know, yield very different historical profiles and technology development profiles. You know, that those are fascinating and I think really important to pay attention to.
Thank you.
Okay, are there other questions in the room? Rajiv? Any? There is. No? Okay, then let me ask, is there a question? I can't see. Okay, well, let me ask a question on behalf then, right? Because there's a lot of students in the room, and being students, they're all really shy. So let me ask on their behalf, right? You gave a slide on how students can get involved, but it's still very high level, right? And students get overwhelmed with this. If you had some advice you wanted to give students on how they would start addressing topics in this space, because there's so many factors they can't control, you know, related politics, spectrum, etc. How do they actually get involved in something like this and do something that has a social good as part of their thesis, for example?
Thanks for that question. Yeah, I mean, I think one of the best ways is to actually, you know, look around you and think about whether there are ways that you might get involved in your local community, or perhaps it's not your local university community, but a place where you've come from. I mean, having direct access to people and situations where there's need, where there's opportunity, to say it in a positive way. I mean, that is incredibly valuable, and just starting to pay attention and listen and talk to people who are facing issues, I think is a great way to start. I'll tell you, my own work in computing and social good started not as a research agenda. I taught a class where students worked on projects for local nonprofits. And they were, almost none of them were networking projects. And so I didn't approach it as research. But we're researchers, so we think that way, right? And so I slowly came to understand a set of issues and essentially to abstract away from the very specific immediate issues that these nonprofits were facing, to start to think about what this might mean if I tried to put it in a research framework. So experience, not necessarily going into it thinking I'm gonna talk to my neighbor and come away with a research problem, but I'm gonna start to understand a setting, and then I'm going to use my researcher capability of abstraction to think then about what might be fundamental about what's being experienced there. I mentioned West Africa, Liberia. I traveled there 8 or 9 times. And I had also done work in disruption tolerant networking. You know what? You put these two things together, and that was a setting where networks were significantly disrupted. I had done a lot of theoretical work. Well, I mean, we'd use some data sets. We tried to connect it to, as much as we could, to some real world settings. But I think paying attention and then starting to practice this abstraction that lets you move from a given situation to something more fundamental in general, that would be my advice. It took me probably 2-3 years of doing these projects with nonprofits before I started pursuing research that was really computing and social good.
Yeah, you've actually hit one of the common problems, right? That a lot of these solutions are not research in general, and it takes a long time, which is why I actually asked if you had any advice for students, because they don't have that kind of window. This is
right.
mostly
Actually, I have one other thing to say about that.
Yeah.
I think we need, as a community, to recognize that this kind of work is important, and that just because there's not some advance in ML buried inside the paper, the work should still get published. And especially for students in the room, as you start to become reviewers, keep in mind that we want to be sharing work that is important, and work can be important in several different ways.
Okay, are there Rajiv questions in the room?
Yes, there is a question, Rajesh. I'm going to hand over to a colleague.
Hello, I'm Himanshu. I have a small basic question.
I can hear you.
Yeah, okay. I'm Himanshu. I have a small basic question. You showed the slide where you showed that, say, 1.5 hours away from Atlanta in Pike County, there was very little coverage. The problem of lack of coverage is pretty much common even in India. So, is lack of revenue as an incentive the prime reason for not having coverage, or are there other reasons as well?
Yeah, good question. I'm fairly sure that in the U.S., the primary issue is that there is no economic business case for providers to go into small communities because they have to deploy the infrastructure, and just the catchment, the region of potential customers is too small, and those customers are often not wealthy. And so, you're not going to get 100% of the people to subscribe. And that means there's a role for, for government, right? For subsidies that help make it possible for those providers not to lose money in doing deployments. There are probably also, there are for sure some additional issues. So in the US, if you look at Native American tribal lands, their coverage is worse, even when you normalize for rurality. So it isn't just the economics. That's an example of that. In many places, it's the economics, but but that's not true everywhere. There are places where the politics are an additional component. Thanks for the question.
Any final questions? Otherwise, back to Rajiv.
Okay. Thank you, Rajesh. Let's, Ellen, it's a wonderful talk. And on behalf of COMSNETS Organizing Committee and Steering Committee, you have a question? Oh, you have a question, sorry. We have one more question. So, Ellen,
sure.
A lot of excitement over here.
Thank you, Ellen, for that talk. As a student, I would like to know if there are any open projects where we could contribute or get involved currently.
Yeah. So, if you're interested, it would be wonderful if you took a look at HikerNet and see whether you are able to make measurements in your own location. And if you're not, I'd be quite curious to know that, so that we can think about how we make the software usable in other places, and maybe doing some of your own data collection. You don't have to use HikerNet. You could use another tool. Is a way to get started on understanding the challenges of mapping and understanding what the environment looks like. You could also try to see what government data is available for your own location. As I said, I know the US situation reasonably well. I poked around the UK situation. Knowing what is being collected and made available in your own region would be a very interesting addition to our understanding of how good the maps are. So those are two concrete things: doing some measurement and then digging into what's publicly available about coverage.
Any other questions from anyone? Last question. No, Rajesh, we don't have any questions now. I think so. Let's thank the speaker for a wonderful talk. I'd also like to mention, Ellen, that COMSNETS conference is very indebted and very grateful to ACM SIGCOM. They've been, so I know whether you know this, probably you know this, that we've been supported by ACM SIGCOM and ACM SIGMobile since inception. So it's been a long time. But I think we are very grateful to all the support we've got from ACM SIGCOM. I remember way back when we started the conference, ACM SIGCOM and IEEE ComSoc. And I think this is the only conference, this, I think, in our view, is the only conference in this part of the world which is supported by ACM SIGCOM, ACM SIGMobile, and IEEE ComSoc. And we are really happy with that partnership. Thanks again. We were really hoping to see you here, but I'm sure that we'll see you in future editions of COMSNETS conference. So on behalf of the steering committee and the organizing committee of COMSNETS 2022, again, a sincere thanks to her. This is the last keynote talk. It's been Ellen, just to share with you, it's been a wonderful last 4 days. People were surprised that we could run this in a hybrid mode. There was a lot of trepidation. I mean, there was prayers going all over that, oh Lord, don't touch COMSNETS. And I think we've been extremely lucky to run it in a hybrid mode. There have been 175 physical participants in COMSNETS. So it's been unbelievable. Thanks again. And Rajesh, over to you.
Thank you, Alan. We usually give out plaques, but because everybody's virtual, we will instead send you a very nice Amazon gift coupon. So look out.
Thank you. Thank you so much. I really enjoyed being with you all.
Thank you for the keynote. We really appreciate it. Rajiv, up to you to close the technical program, I guess, or Amit?
Amit is not here. So again, big thanks to Ellen. This is the last keynote talk of the conference. Actually, the main conference ends now. We have 3 workshops tomorrow. So Ellen, we are going to meet tomorrow. Everything is business as usual. We'll run the 3 workshops in a hybrid mode. Just stay safe and healthy. The same hall, Sigma 1, Sigma 3, and the Indian Affairs. And again, also inviting all the organizing committee members and volunteers to please join for dinner at the Ithaca restaurant, right? So all the volunteers who work very hard and organizing committee members, please join us over cocktails and dinner at the Ithaca restaurant right next door. Thanks again, and we hope to see you all, particularly our students, tomorrow. And that is the last day of COMSNETS. Thanks again. See you tomorrow.
Okay. Bye, everyone. Thanks, Ellen. Have a great rest of the day.
Thank you.
Thanks, Rajesh, for sharing. Thanks, Ellen, once again from Bangalore. Bye.
Bye-bye.
Bye.